So in this video, we're going to go through how you might be asked to represent molecules in your exam questions. By the end of the video, you should be able to describe the different formulas plus the advantages and disadvantages, so therefore why you might use them. And you should be able to write or draw a given molecule using any of the formula we go through. And last, you should be able to recognize a molecule from any of the formulae. So there are 5 formulae you need to know. First one is what is called empirical. Second one is molecular. Third one is structural. Fourth one is skeletal. And the last one is displayed. Now it's very important that you learn all of these names, as it's very common in the exam questions for them to ask for one of these formulae to be given as your answer. So even if you have the right information, but you've chosen the wrong formulae, you might not get the marks. So they normally ask for one of these formulae, or they sometimes ask you to draw the molecule. If you're asked to draw the molecule, it is best to go with a displayed formula. Sometimes you'll get away with a skeletal or a structural formula, but if you draw the displayed formula, you've covered all your bases. So the best way to go through these is with a couple of examples. Now in displayed formulae, you have to draw every atom and every bond involved. This is the most detailed of the formulae, as it provides information on which elements are involved, how many atoms of each element, and also information about the structure. Now, skeletal formulae are normally used with organic molecules. Now, you can have very large organic molecules, and thus drawing the displayed formulae for these molecules would be unnecessary and could also complicate the point you're trying to make. So skeletal formulae show the basic skeleton of the molecule. Now each endpoint or corner point represents a carbon atom. Now in a skeletal formulae, you do not have to put the bonds to the hydrogens. It is presumed that for every carbon, there are enough hydrogens so that it is saturated, so that all the bonds are taken up. If you have atoms present which are not carbon or hydrogen, you have to put the atom and the bond going to that atom from your carbons. And also if you have, for instance, a hydroxide group, you need to put the H attached to the oxygen. I'll just quickly draw a different example. In this case, you still have the 1, 2, 3, 4 carbons, but on the second carbon, it's attached to an oxygen, which is then attached to a hydrogen. But in our example we're going through, it's a hydrocarbon, there are only carbon and hydrogen involved, therefore you can just draw the basic skeleton. Now, where people make mistakes here, they forget that the endpoints also represent a carbon. So this has 4 carbons, not just the 2 points. Now, the structural formula shows all the atoms involved, and whilst it doesn't normally show the bonds, they can be inferred from the structure. The structural formula needs to be unambiguous in terms of the structure it's showing. Now this can be more complicated when we do more complicated organic molecules such as aldehydes and ketones and alcohols, and there are certain rules for this, but for now we're just going to keep it basic. So for our alkane, we start with the CH3 group, which is here. On the next carbon, there are 2 hydrogens attached. On the third, again, 2 hydrogens. And the final carbon, there are 3. So you basically take each carbon, put the atoms which are attached to that carbon in one line. But from this, you should be able to infer the structure involved. Now you can see as we go from right to left, it's becoming more simple. Now the molecular formula is an ambiguous formula. You can have different isomers with the same molecular formulae. So the molecular formula just has which elements are involved and how many atoms of that element. So we have 4 carbon atoms and we have 10 hydrogen atoms. So from this you cannot infer the structure. It's an ambiguous formula. And last but not least is the empirical formula. Now this is just the simplest ratio of atoms in your molecule. So in this case, our empirical formula will be C2H5, because this is the simplest ratio between the numbers of atoms of carbon and hydrogen. Can't simplify it anymore and still have integers involved. Okay, so these are our 5 formulae. I'm just going to do one more different example just to highlight the key points. So instead of having an alkane, we'll quickly go through an alkene. So again, the displayed formula, every bond, every atom needs to be displayed. Now with your skeletal formula, it's still only carbons and hydrogens involved, but with the double bond, you need to show it. Okay. Now with the structural formula, again we start with the CH3. Next comes the CH. Now here, we do actually need to show the double bond. If it's a single bond, you don't need to put it, but double bonds are normally put to make it easier to read the structure. Next we have another CH, and finally the CH3 on the right hand side. Now the molecular formula for this, we still have 4 carbons, but this time we only have 8 hydrogens. Now the empirical formula for this, the simplest ratio, is CH2, because we have double the amount of hydrogens than we do carbons. And finally, one last example. This time we're doing a ketone, which you haven't done yet in this course, and you will do next year as part of the A2 course. Now, skeletal formula, again you put in the carbon chain, but because we have an oxygen involved, this needs to be put separately. Now notice with the structural formula, I have a double bond, but it's a double bond to an oxygen. So you don't need to put that in your structural formula. It's presumed knowledge based on the amount of atoms and the amount of bonds they would make. So with the molecular formula, don't forget to include the oxygen, even though it's just one of them. And in this case, the empirical formula is the same as the molecular formula. There's only one oxygen, so there's no number you can divide by to get a smaller integer. So hopefully these 3 examples will help you to understand what is expected for each of the 5 formulae and will help you realize what you need to put in your answers in your exam questions. So hopefully you now know the different formulae you might be asked to write or draw and why we have different types. You should be able to write or draw the formula of a given molecule. And hopefully, if you were given one of these formulae, you should have an idea of what the molecule they are talking about is. If you're unsure about any of this, watch the video again.